Now the next indeterminate form is 0 into infinity. That is, limit of f of x as x tends to a is 0 and limit of g of x as x tends to a is infinity. So if we want to find the limit of the product of f of x and g of x, so that f of x tends to 0 and g of x tends to infinity, right? So in this case, what do we do is we rewrite the given expression as keeping f of x in the numerator, the g of x is written as the denominator of denominator. So therefore effectively we get 0 by 0 form, and which we can evaluate using the L'Hopital's rule. So let us see one example based on this. Alright, here we have to evaluate the limit of log of sin x whole multiplied by tan x as x tends to pi by 2, right? So this is equal to, now let us see which of this is 0 and which is infinity. Now if we put sin x with x as pi by 2, we will get sin of pi by 2 as 1 and log of 1 is 0. So therefore the first term is 0, and we know that tan of x, when we put x as pi by 2, tan of pi by 2 is basically approaching infinity, right? So therefore here we have first term tending to 0 and second term tending to infinity. So therefore rewriting the given expression, we keep log of sin x in the numerator only as it tends to 0 divided by tan x, we write it as 1 upon tan x in the denominator. Alright, so that is nothing but limit x tends to pi by 2 log of sin x whole upon, we can write 1 upon tan x as cot x for simplicity, right? Now since we are getting 0 by 0 form, let us use the L'Hopital's rule to evaluate this. So now we have to differentiate the numerator first, that is log of sin x, the derivative will be 1 upon sin x multiplied by derivative of sin x, which is cos x, whole divided by derivative of cot x is minus cosec square x, right? So this gives us, now we have to simply evaluate what does this result into. So that is limit x tends to pi by 2. Now if you see the cosec square and sine, both the terms are in the denominator. So therefore sin x and one term of cosec x will nullify each other. So therefore what we are left out with is just cos x whole divided by cosec x. One instance of cosec x will remain. Now if you put the value of x equal to pi by 2, here we will get minus cos of pi by 2 is 0 upon cosec x. We know that cosec of pi by 2 is 1, so therefore that gives us the answer as 0. So therefore this is a very finite number, so that's the limit.